We're going to do this one a little bit differently. This is not fiction. Maybe the first book we've read that wasn't fiction. This is a sort of a biography of a woman named Katherine Johnson. The book is called A Computer Called Katherine. Some of you may know this story already. Some of you may just look at the title and wonder what the story is going to be about. And we can use the pictures to help us here. So let's drive on. Everywhere she went, Katherine counted. She counted her steps to church. She counted the plates on the dinner table. She even tried counting the stars in the sky. Most important of all, Katherine counted the days until she could start school. Finally, at age 5, she followed her brother hundreds of steps to the 2-room schoolhouse. An excellent student, Katherine devoured thick books and added numbers at the speed of light, so the teacher decided she would skip first grade and start in second. But Katherine was such a fast learner, she later skipped 5th grade too. Before you could say, mathematician, magician, she was a grade ahead of her older brother. Any of you know this story already? Any of you wish you could skip 5th grade? Katherine loved math because it was easy to see if an answer was right or wrong. Meanwhile, most everyone in town was arguing about right and wrong. Some people said it was wrong for children with different skin colors to attend the same school. Others said it wasn't right for women to work at the same jobs as men. Their arguments seemed wrong to Katherine, as wrong as 5 plus 5 equals 12. She believed everyone should be treated the same, so she kept working hard in school and dreamed of a future when all people would have equal rights. What is 5 plus 5? Oh, that's right. Katherine finished 8th grade when she was only 10 years old, but her town didn't have a high school for black students. Determined to keep learning, she counted the dusty miles, 120 in all, as her family moved closer to a school she could attend. There, she took an exciting math class called geometry. She learned how points and lines made shapes, triangles, trapezoids, and perfect parallelograms. I noticed on the iReady test, some of you guys are way ahead of the curve on geometry. I don't think it's been taught yet here in Virginia for you guys, has it? And her love for math grew exponentially. So if we look at the picture, move a little bit to the left of her head, you see the A with a little 2 above it. What that really means is A times A plus B times B equals C times C. Seems silly, but if A is 3, 3 times 3 is 9, and B is 5, 5 times 5 is 25. 9 plus 25 is 34. So whatever the square root of 34 is what C2 is. Anybody know what the square root of 34 is? Somewhere between 6 and 7, because 6 times 6 is 36. I'm sorry, somewhere between 6 and 5, because 6 times 6 is 36 and 5 times 5 is 25. So somewhere between 5 and 6, closer to 6. Those are called exponents, by the way. At 15, Katherine started college. She flew through every math class at West Virginia State, so a professor taught harder classes just for her. In advanced geometry, she plotted points on a graph. Don't you wish your teachers were that good they could figure out how to teach classes just for you when they see that you're bored? I wish I was that good a teacher. She plotted points on a graph. When she connected the points, they created a beautiful U-shaped curve called a parabola. It was love at first sight. So when you throw a rock up in the air, it goes up, 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 and gravity starts taking over and losing pressure on, or gaining more pressure on it, more pressure than your shove up in the air did. And the arc of the rock comes back to the earth. And we call that path that the rock travels a parabola. It was love at first sight. After graduation, Katherine became a math teacher. Back then, people said women could only be teachers or nurses. Katherine knew that was wrong as 10 minus 5 equals 3. She believed women could be anything, scientists, lawyers, or mathematicians. So she set out to prove it. Katherine discovered a research center in Virginia that was hiring women, mathematicians. They were called computers because they made calculations that helped the men engineers design airplanes and flight plans. To Katherine, it added up to the perfect job. All day long, she punched buttons on a calculator just like the other women. She solved long math equations just like the other women. She wrote answers on huge data sheets just like the other women. So, was this before we had computers like we know today, like our cell phones and things that are computers? But Katherine wasn't like the other women. She asked questions. Lots and lots of questions. What were her calculations used for? Why were they important? How did her answers help design airplanes and flight? The men engineers noticed the woman who asked intelligent questions and how quickly she solved difficult math problems. So they asked Katherine to join their space team. Its mission, send America's first astronaut into space. Katherine said yes. Then she discovered that women weren't allowed to attend the group's meetings. She knew this was wrong too. As wrong as 5 times 5 equals 20. We just did 5 times 5, didn't we? So she asked if she could go. Women don't go to those, the engineers replied. Is there a law against it? Katherine asked. No. So Katherine showed up to the next meeting, ready to work. Astounded by her geometry skills, the team asked her to calculate when America's first space flight should blast off, and Katherine agreed. But first, she asked questions like, where should the rocket splash down? How high should it fly? And what time should it land? With that information, Katherine carefully computed the rocket's flight. A beautiful U-shaped curve. What was that word again? It started with a P. When we throw the rock in the air, a parabola. Next, she worked backwards to figure out the time it should blast off, and then she began counting the days until launch. On May 5th, 1961, Alan Shepard blasted off, following Katherine's flight path. He soared into the silvery sky. 15 minutes later, he splashed down in the Atlantic Ocean, right on schedule and right on target. Soon, Americans began dreaming of a longer flight around the entire Earth. To figure out the math for this long, complicated trip, the engineers decided to use their new room-sized computer that worked much faster than people. But astronaut John Glenn trusted Katherine more than a machine. He wouldn't step 1 foot onto the rocket until she said that the computer's calculations were correct. Happy to help, Katherine checked every number. On February 20th, 1962, John Glenn became the first American to orbit the Earth. What's that word mean? Orbit. So let's look at the story so far. They were dreaming of a longer flight. Where's the longer flight going? Around the entire Earth. John Glenn became the first American to orbit the Earth. What does that mean? You guys want me to tell you the answer, or you got to figure it out? Then people began wondering if an astronaut could travel all the way to the moon. Both the Soviet Union and the United States wanted to be the first to land there and win the space race. Katherine knew this flight was incredibly long and dangerous. Every calculation would have to be perfect. One math mistake and the rocket would zoom right past the moon. As NASA's computer hummed and computed a flight path to the moon and back, Katherine went to work too, double-checking the machine's calculations. But this was the most complicated geometry problem she had ever seen. One of the points, the spacecraft was flying incredibly fast. Her target, the moon, was constantly circling the Earth. And the Earth was spinning. Some people thought the problem was too difficult to solve, but Katherine knew that was wrong. As wrong as 25 divided by 5 equals 4. She's right. That's wrong. But what is 25 divided by 5? 10, 9. Ignition sequence starts. Heart racing. Katherine leaned close to the small television screen. 7, 6, 5. She held her breath as the powerful flames exploded off the launch pad. 4, 3, 2, 1. We have liftoff. The rumbling rocket slowly rose above the ground, above the smoke, above the clouds, and then disappeared into the ink-black space. 4 days later, Neil Armstrong took his first steps on the moon. Katherine smiled and began to count. So, true story. The picture in the black and white picture with the woman looking at you is Katherine Johnson. And it shows the Mercury project. It shows the Apollo. Why does it look like there are two moons in the picture? Why does it look like there are two moons in that picture? No such thing as a dumb question. Katherine Johnson said that. So, just in case we haven't figured out the answer, the picture that shows the lunar landing mission profile, the first picture, the moon on the bottom, that's the rocket ship traveling from the Earth. It circles around the Earth a couple times, gains more and more speed, and finally when it has enough speed, it breaks away from the gravity that is Earth. And it flies this long path all the way to the moon. But it's going so fast it has to slow down at that point. So it starts circling the moon, and it gets closer to the moon each time and uses that to slow itself down until the moon captures the spaceship in its gravity. And from there, they drop the little tiny spacecraft that was inside the bigger spacecraft out. And that's what Neil Armstrong rode to the moon. But the moon's traveling around the Earth. So by the time it was time to come home, not so long later, but by the time it was time to come home, the moon had moved. And so the new math for the return trip had to account for the moon being in a new position. That's really, really cool math. In 2015, President Barack Obama gave Katherine the Presidential Medal of Freedom, the highest honor that could be given to a civilian.